Right, year 11s, we'll continue with further trigonometry. Um, from previously, we had the ratios for sine, cos, and tangent. What we look at today is the addition formula. Is when we start with cos, we'll do the same similarly with sine and tangent. Is when you have cos of the sum of two angles or a difference of two angles. Now combined with your exact values, once you expand this formula to those expressions. If you know the exact value assigned to u and v, for example, let's say 60 and 30 degrees, then you can evaluate in exact form without a Gauss calculator. Okay, so it's about using those formula and use your algebraic skills to simplify and get an exact answer. With those formula, you need to know cos and sine. I would concentrate on the sum first. Just remember the way the sum is equal to. Have a look at the detailed workout in a textbook. It's a little bit too hard to explain through this video, so I'm not going to include it, but you need to get an understanding its application about um, angles in a unit circle and various triangles involving it. So cos of bracket u plus v is equal to the product of cos uv minus the product of the sine uv. Okay. Now, when you do a difference, all you need to do is, if you look at the first formula, if you substitute that plus v by plus negative v, so if that becomes a negative, it will affect that v that will be negative v, and this one a negative v. You remember the property of symmetry for the negative angle for cos and sine. Cos of negative v is the same as cos of v, so the first term is unchanged. But sine of negative v is going to be negative sine of v, and the negative here will times another negative will becomes a plus. All right, let's look at an application. So an application here is of using the addition formula. So think you have two options. So you have, is it a sum or is it a difference? So if you think about a difference, you need to remember your exact values. So the main angles are 0, 30, 45, 60, and 90 degrees. What you do here is 75. First, think, let's say I'll go with the wrong one. So I say I'll go with the difference. It would be 90 minus 15. We don't have an exact value for cos of 15 degrees or sine of 15 degrees. So think about, move on to a sum. What would be a sum here with the 5? The only angle we know with ending in 5 is a 45, and 75 is 45 plus 30. We know the exact value for 45 and 30, so that's what we're going to use. So you substitute here, it's a sum of two angles. You use the first formula over here. That's your expression that you obtain. You substitute by your exact values. So it's for you to practice those as well. When you have a sum or difference of fractions, always combine in one fraction, simplify, and then you need always rationalize your answer. You will also have an addition formula for sine. Here for sine, when you do the sum, it's sine cos, cos sine. Okay, so u and v are in the same order, so it's uv, uv, and you start with sine cos, and the next one is cos sine. You swap it around. Now it's a good idea to start remembering this formula in this order, so sine cos first, because the second formula is when you have a negative v, it's the same order, the second term now, the one with cos then sine, has a negative operator. Okay. So again, those are formulas that you need to remember. So here, two examples using the sine. So 75 is the same as before, so it's going to be 30 plus 45. 15, you can't have a sum, so think about a difference, which is actually 45 minus 30. So 45 minus 30 is 15. You replace, substitute over here. So with the first one, it's a sum, it's a sine. You substitute with the formula. Same process as the example that we done previously, or example 10. Here you have a difference, slightly different formula with a minus here. Combine as one fraction, simplified, rationalize, and you get your answer. Okay. All right, moving on. Next one is tangent. A little bit more elaborate. Those with the proofing, the way it's obtained is, if you look at the proofing, is, remember tangent is a ratio of sine over cos. So they do sine of u plus v over cos of u plus v. And what they do is they manipulate this expression that we've done from the previous formula to get those expression in terms of tangent for u and v. Okay. So probably the first one is this one to remember. Again, if you have a minus v instead, it will be, for this second term will be a minus, because remember tangent is an odd function. And here that term with a minus, that's a negative tangent of v that will become a plus on the denominator. So here, the application, you have tangent of u and tangent of v. It tells you you need to prove that. So u and v are acute angles. So keep that in mind. When it says acute angle, it means it's in the first quadrant. So what you do is you do tangent of u minus v. You use the expression that'll give you your answer after simplification, which is equal to 1. And what tangent is equal to 1 is going to be pound 4, as the function tangent is a 1-to-1 in the first quadrant. Okay. All right. Then we're gonna look at double angle formula. So before we look at the addition, the sum of two angles or the difference of two angles. Now, if those angles that we had before, u and v, are the same, then it becomes an angle property, and it will only work for the sum, because if I have u plus u, it's 2u, but if I do the difference, u minus u will be 0, so it will not work for the difference. What I like with the double angle formula, well, the application is for later on for anti-differentiation that you will do next year, but it helps you. The formula are a bit more concise than the previous one for the addition formula, but it just helps you to remember the addition formula. So cos of 2u is cos of u plus u. If you use the addition formula and you simplify, you end up with this expression, which is a difference of the square of cos and sine. Do remember that also that cos squared plus sine squared equals 1. And if you rearrange it, it's the Pythagorean identity in the unit circle. If you rearrange it to make sine squared or cos squared the subject, you can substitute to get rid of sine squared, or you can substitute here by, to get rid of cos squared. So you have the first formula is the main one, but you have sort of resulting expression that are only either in cos or in sine. That could be useful depending on the given information. Like they can give you values in terms of cos. You can find cos of 2u. The same, we're gonna have a sine of 2u. That should be the I don't know, for me it's the easiest to remember. It's 2 times sine of u times cos of u. And for the tangent, you do the ratio and you simplify. That gives you 2 tangent u over 1 minus tangent squared of u. The fact that it's over here you have a minus, it relates to the addition formula for tangent. It's another way to remember it. Same here with cos of 2u, you notice it's a difference. Okay, so it will be a minus when you do cos of u uh, plus v. And when you do for the addition property of sine of u plus v, because here you have two terms, you know it's going to be a sum, because that's the only way you can get you can regroup the like terms under a factor 2. Okay, so now we have an example. We need to find the double angle property for you use the angle formula to find the sine and the tangent. Now you know tangent of theta is 4/3 and it's in the first quadrant. The first thing is, because the tangent is given as a fraction, always use that being well, it's the rise over run, but it's also you opposite over u adjacent. So opposite over u adjacent, that's your theta, and using Pythagoras you can find the length of the hypotenuse, which is an exact, not a surd. It's a rational value. So what then you can do is, from that you can express sine theta and cos theta using that right angle triangle. So once you have sine theta and cos theta, you can use a double angle property to determine sine and tangent. So here we have sine of 2 theta. You use the expression, you substitute, you simplify your answer. And we do the same with tangent of 2 theta. It's 2 tangent theta over 1 minus tangent squared. You substitute and you simplify. Okay. Notice that is negative. You see, when you tangent theta, your angle is in the first quadrant. If you double your angle, forget what I'm saying. It's not always the case. I was going to say you move to the second quadrant, but not necessarily. So let's move on. Again with double angle formula. So here with proofing, again, a reminder, you need to prove the equality between two expressions. Do not mix up the expression. Start on one side, and there's no better side than the other. So I would say start with the left-hand side most of the time. 99% of the time, start with your left-hand side. Rearrange your expression, do whatever necessary, use the known rules to get to the right hand side. Okay, so let's look at part A. You have um, you have this expression on the denominator and the numerator. Now, if you know your double angle formula, you can substitute using the double angle formula. So here, that left-hand side, the numerator is sine of 2 theta. The denominator is the exact expression of cos of 3 theta. The ratio is tangent. It is indeed equal to the right-hand side. Also, always annotate that the denominator has to be different from 0, otherwise it's invalid. You can't divide by 0. Part B. You start with the left hand side, so you have this one, but notice on the right hand side it's one fraction, one denominator. So the first thing you do is combine those two fractions into one. So you need to find a common denominator, which is the product of the two. We multiply the denominators to get the common denominator here. You write the numerators will be through equivalent fractions, we'll get those terms. Okay, and that is the numerator is the formula for the sine of two angles, and the denominator, imagine you have a 2, it will be therefore half of sine of 2 phi, which is the denominator is related to the double angle property and the numerator is to the addition formula. Then what you do is, as you divide by half, you rearrange it to make it multiply by 2, and that is what we have on the right hand side. Again, just mention that the denominator has to be different from 0. All right. Over here, you have a sum of two fractions. Again, with two fractions, they need to have the same denominator to combine as one. You multiply the two, it's a difference of two squares. That gives you cos squared theta minus sine squared theta. You multiply, you do a cross product, so that side will become cos theta minus sine theta, and that you get cos theta plus sine theta. The sine theta cancel out. That will simplify to the two like terms, that 2 cos of theta on the numerator. Then what we need to do is we make it an equivalent fraction to multiply by sine theta to make appear that dual angle property on the numerator of sine. So we get on the numerator sine of 2 theta over cos of 2 theta times sine of theta. Now sine and cos have the same angle, so that's tangent. And 1 over sine is the same as cosec. So now it is equal to the right hand side. Alright, last one. I just changed a little bit the working out. I don't like the working out that the way it's done on the textbook, so I did change a little bit of the order. So what you do again, you start with one side. Start with the left hand side, okay? Now, with the left hand side, you have a mix of trigonometric function as well as reciprocal trigonometric functions. So what you need to do first is replace your reciprocal function as the respective circular function, okay? And for each bracket, it's a combination of fractions. You need to combine them as one equivalent fraction, or one fraction with a common denominator. So that left bracket will have cos of A, the right bracket will have sine of A, and you have those two new numerators for the respective fractions. It's a product, so we can multiply them together. For the numerators, what you do is you you multiply the numerators by a and simplify the terms. What you will get is that equivalent. Now that's simplified to cos A sine A. Okay, and now notice a little bit the answer. Well, it doesn't relate to any of the angle properties. So a little bit of a trick that here that we're going to be using is this is a fraction of a 1, and 1 is the same as using the trigonometric property is sine squared plus cos squared. Okay. Once you've done that, what we do is we're going to divide by the numerator. So we divide by cos A sine A. So the numerator becomes 1. And we divide all of that to the respective term. So as we divide sine squared by those two, 1 sine A cancel out, and what's left is sine A over cos A. And here you have cos A, the second term will be cos A left sine A. That's tangent of A, and that's cotangent of A. And hence we have the right hand side. Alright, so it's a little bit of manipulation, a bit of practice. You're going to have to mix up everything that you've learned in chapter 14, from including your exact values, your symmetry, your reciprocal circular function, and your identities. And also from this part, the addition and the double angle formula. All right, and that's it for this exercise. See you later.